Hey, this is David Hilster. I am a critical thinker, dissident scientist, and this is my live stream. If you've never been here, I am trying to get you to be science woke. Those of you who are my subscribers, it's a chance for you to ask me questions live, and I can answer those. I'm going to be going till only about 10:15, 10:30, depends on what's happening here. Kind of got an early morning tomorrow, so I am here, try to get here every Friday. And of course, we have tens of, well, at least thousands and thousands of physicists and scientists and engineers and lay people around the world who've been looking at mainstream physics and cosmology for many, many years, many decades, looking at it in depth. And in fact, have found problems with it and have also come up with solutions, new solutions to the problems. And so if you're one of those people who read about the physics and the cosmology going on and you just don't believe this stuff, well, I'll tell you, a lot of us don't. In fact, a majority, in my opinion, and also other people's opinions of physicists, actually, and scientists and engineers, do not buy a lot of what we call theoretical physics and astrophysics. So really happy to be here tonight. I'm going to get myself going here, make sure I'm live. Yep, there I am. I see that. And if you have any questions, please pose them. Of course, I have things I do like to talk about and things I will talk about during this session that I sort of put together. And I've got to stay, you know, when I do live, I say a lot. I've got to stop doing that. But anyways, thank you so much for those attending. I see, there I said. Keep saying, I was watching one of my recordings. I said, when I make recordings, I don't say because I'm pretty focused. When I'm, doing these live streams, I've got to throw that out. But anyways, I'm going to, see, there you go. I'm going to try to take a look at some comments while people are still coming here. And I will be doing that. And for those who are here, I'm going to be talking about a couple things. The news, physics news, I like to bop through that. But I'm going to go through a video from one of my favorite people on the planet, Dr. Alexander Unzicker, who interviewed a physicist, David Gross, who is a Nobel laureate. And he is one of the most supposedly influential and most important theoretical physicists out there. And I do want to show and go through the video because it's absolutely fascinating to listen to these guys. And a lot of people say, hey, Dave, you're talking about the unicorn world. Well, this guy absolutely is the unicorn world. And so I know it takes a little while for a lot of my subscribers to get here. I'm going to go through my comments. So those who are here, you can sort of see how I do this a little bit. I've already gone through them, but I will take a look at them. It's pretty interesting, but I will go through my comments. So let me get to the comments part here and give you a gander of what I see. This is, of course, the channel. When you get your channel, you get to see the comments. I have this new interface now here. And when you go to likely spam, a lot of times it's because a person will put a lot of stuff in there. Most of the time it isn't spam, and the spam detectors, of course, aren't always that great. But this one says, yeah, we need a therapist. I think scientists is totally lost. I'll read this. David, you may be interested in this. I kind of landed on this weird science world by accident. What I was looking at is why the mind makes mistakes, why humans often come to the wrong conclusions. That is actually my primary interest, how the mind works. It is very interesting, too, because one of the things we had in 2015 at our CMPS conference here in Boca Raton, Florida, well, we had one person fly all the way from England, and he was a sociologist, and he was really looking at what the sociology is of people who defend their positions, the relationships of people, and the sociology of the way science works, because a lot of times, as we know, it is groupthink, group thought, and if you go against the group, you're not part of the group. It doesn't matter if you're completely right, the group's right, you're wrong, that kind of thing. So it is interesting to look at the mind, the way we think, that kind of thing. So it says, but to show people how mental models can get twisted, I grabbed the Big Bang Theory as a test case. The interesting thing is when I look at where the mind could and would make mistakes in that theory, the whole theory changes to that of a perpetual universe. So he says, I show the Big Bang is just wrong, which is very interesting. So absolutely interesting comment here. I got to make sure. Hello, everybody. I appreciate you joining in. I'm just going to go through some of my comments before I get to the main thing. If you're just joining, I want to make sure you don't pop away. I'm going to be talking and going through the video of a recording of David Gross, one of the particle physicists, and for sure, I'm going to go through and show everybody how interesting that is, and that's thanks to Dr. Alexander Unzicker. So it says, with sound, laugh out loud. Yeah, okay. Hey, I got Lisa here. How are you doing? And, yep, good evening, Dissident Dave. Not sure how long I can stay tonight. Well, me neither. And Lisa, what are your thoughts on Immanuel Velikovsky being blackballed from science community in his day? Super sorry, I'm using talk to text. No, that's not bad. I was just going through some of these comments. This guy, I will get back to him. Yeah, the Velikovsky, for those who don't know, he's a scientist that's very well followed in the electric universe. I believe he states that Venus came in about 30,000 years ago into the solar system, came flaming in, got into the orbits the way they are. I'm not real. Don't look. Talk to me about the or ask me about the super specifics. But yeah, the way I look at it is this. I'm not a big Velikovsky fan or even Electric Universe fan myself. I am a fan of them because they are creating critical thinkers. They're not afraid to come up with new ideas, and that's awesome. I mean, you should be able to question everything from evolution to climate change to global warming to particle physics to the Big Bang. Everything should always be up for grabs, and it should always stay that way. And I applaud the Electric Universe because it creates a lot of critical thinkers. I know there's a spectrum of people too. There are people who like the ancient petroglyphs and how that sort of would relate to happenings in the solar system and the universe. Other people are attracted to the idea that the universe is much more electric. And other people are attracted to because of Velikovsky. But absolutely, in fact, that's a good point to point out that Velikovsky, was ridiculed, and none of these people should be, including the Electric Universe people, because, like I said, science is open to critical thinking, to criticism. Everything's up for grabs all the time, and it should always be that way. So, and I would like to learn a little bit more about him. So, anyways, this guy's talking about that the Big Bang is just wrong. But even more interesting is that when perpetual motion falls out of testing the theory and trying to fix it, dark matter is not in the new theory. It is wrong. So is dark energy. So is antimatter, and it's not what we think. Black holes have nothing to do with gravity. The whole thing changes in a different worldview. Very interesting. This sounds a lot like the particle model my dad and I are working on, and is definitely. We'll want to take a look at this. You may find this a good read. I will take that out. Check that out. I will click on this and say, yes, this is accepted. This is definitely not spam, and it's actually very interesting. So that's what I'm doing here while we are getting more people here. We got up 7 people. Welcome, everybody. I am going to be talking again about, I'm going to go through the video with about David Gross, and you're going to see a unicorn particle physicist, one of the most respected in the world, and you are going to hear with your science therapist why this is just sad, hilarious, scary. I'm not the only one. This is all to the credit of Dr. Alexander Unzicker. So I'll be doing that soon. I got one held for review here. The same thing in mainstream. Oh, that's a good one. I'm going to check this off. Good one. And this article, read more. Someone can find French. Absolutely. So I go through these, and but since I'm going to be talking, and I do have a good little quorum here for us, let's go forward and take a look at this. Very, very interesting. Again, this is from Unzicker's Real Physics. I would highly recommend that you subscribe to that bell. He has, I have to take some credit that he has gotten a lot more subscribers, and he definitely should, because he's one of the great warriors out there going against mainstream and the unicorn world. He openly states openly states that particle physics should be all thrown out starting around 1930. I agree with him, and so he did this interview. I'm not sure how he got in there, but you're going to see. Definitely worth. Oh, here I go. Yawning. Don't do it, Dave. I'm going to have everybody yawning here. Okay, so let's take a look at it, and I'm going to mute myself because otherwise we are going to. And if you see me jabbering away, then I would say go ahead and let me know, because I have a tendency not to click on the. That's why I had to restart this whole thing, because the control panel, I can't have both my mic and this going over and hear it myself. So I'm going to mute myself right now, and let's listen to the part of this video.
Welcome to Real Physics. This is an interview with string theorist and Nobel laureate David Gross. I do not really share many views about theoretical physics with him, but that particularly became obvious at the end when we talked about Constructing Quarks by Andrew Pickering, which I think is an excellent book about particle physics. But he certainly made a couple of interesting points. And it was news to me, for example, that physics can ignore gravity. It was news to me that quantum chromodynamics essentially contained no uncalculable numbers, as he said. It was totally news to me that Dirac, one of Dirac's large numbers, can now be calculated. And it was news to me that Dirac predicted a change of the fine structure constant. I think that would have been news to Dirac too.
This guy, Alexander Unzicker is a hero of mine. Actually, he's I've been touting his work so much. He really wants to do some work with me, and I have some ideas about how we can do that. But you notice how he says, oh, and this guy talks about Dirac's, the fine constant, etc., etc. It's not really important that you understand these concepts. It's really not important. What's important is he's saying, oh, that would be news to Dirac, meaning, this guy is talking about things. He's saying, oh, that gravity doesn't matter. That Dirac, that they can calculate these constants. What he's saying is, this guy is saying lots of things that aren't true. And he says, this is news to Dirac. So that's what you have to hear. You don't have to hear about, listen to the exact details. Let's keep going.
But anyway, I think this is an interesting document about one of the most celebrated physicists of modern times. And listen yourself. Yeah, thanks for giving an interview, Professor Gross. In your talk today, you were mentioning a kind of a philosophy of Albert Einstein. He said that regarding fundamental constants of nature, he said that he's not satisfied of numbers. He said that I can't accept a theory in which an arbitrary number appears that the mood of the creator could have chosen it just another way. And so you would agree on this statement?
Yeah, I certainly hope so. I think it's a fantastic challenge. And so, in a sense, that's a overarching motivation and challenge to theoretical physics. I also think that, to some extent, history gives us evidence that we're moving in that direction. For example, if you consider macroscopic physics, the properties of atoms and molecules and amino acids and people, all of that we understand actually in a theory which contains almost no adjustable parameters. That's the theory of quantum.
Did you see? I think it's really great how he's got a camera. Dr. Alexander Unzicker has a camera on himself, and he switches it over at the perfect time because this guy just said, let's go back and listen to what he just said here.
In that direction. For example, if you consider macroscopic physics, the properties of atoms and molecules and amino acids and people, all of that we understand actually in a theory which contains almost no adjustable parameters.
Look at that look on his face. For those who don't know, one of the big criticisms that Alexander Unzicker has, you can read this book, you can read his other book, Bankrupting Physics, all of his books, they're all great. He talks about one of the biggest problems is that they have all these variables. They're adjustable variables. Think of it this way. The way the physics world is working, there's two things that are going on. Number one, he's lying. So he's like, look at his face. Look at Alex. He's looking at him like, are you saying this to me? You're saying this with a straight face that you're saying there's almost no adjustable variables. And there are at least 19, maybe 23. Okay? What does that mean? What it means is, and if you're a layman, like, Lisa always says, "Oh, I'm a layman." No, she's pretty smart. Here's the way you look at it. You have your standard model of particle physics with quarks and Higgs boson and W and Z particles, all this kind of stuff, gluons. Don't worry about it. And then what we have is that for it to work, we have these adjustable rotating buttons that you can go. You can imagine one of those old movies where they pretend to have a really complicated machine and they got all these buttons and switches and stuff. And you can I got to adjust this one over here and this one over here. And okay, now it's working. Oh, we got something else. Okay, well then with this one over here and this. So what they do, I mean, what this guy has a conflict is when you listen to these guys, what they write about, what you study, what you read about. This guy is going completely against it. And Unzicker's his has to sit there because he knows if he just goes at him, this guy's going to just stand up and go away. Well, this is 31 minutes. Guess what happens at the end? I'm spoiling it for you. Okay, so that's what's going on. He's just looking at him like, no, you've got 19 or more adjustable variables, and that's just basically fudging factors that you can dial around so things work. Think about it. That's why he's looking at them, this guy, like, these guys are crazy. This is a unicorn world. Onward.
That's the theory of quantum mechanics, atomic theory, molecular theory, theory of atoms and molecules. What goes into that theory are the principles of quantum mechanics, the existence of some things like the electron and nuclei. But you don't need to know the properties of nuclei. There are no... And two numbers. One is the mass of the electron, which establishes the size of atoms, together with the fine structure constant, which measures the value of the strength of the electric field. And in some sense, with that one-dimensionless number, the qualitative and quantitative properties of just about all of the stuff that makes up everyday life, including us, and the properties of water, we can calculate in principle. Of course, in practice, we don't do that, but in principle.
Did you see his face? He's talking. You see, look at this. Look at these unicorn guys. They talk and talk and talk. We can calculate this, but in practice, we don't do that. Let's go back just a little bit and watch this and watch the reaction of, I mean, he's literally contradicting himself as he goes, and Unzicker's having to bite his tongue and his lip going on about this. Let's go back here and watch this.
Qualitative properties of just about all of the stuff that makes up everyday life, including us, and the properties of water, we can calculate in principle. Of course, in practice, we don't do that, but in principle, we think we could.
Let me point out what I think is seemingly in contradiction, because you also mentioned that we have our standard model of particle physics, and you call that a wonderful achievement, but at the same time, the standard model of particle physics requires a lot of these arbitrary numbers that Einstein had.
19 in the standard model.
How does this?
In the standard model, there are, the order of a dozen or two.
You see what he's doing, right? I mean, this guy is talking about how he can calculate everything, and maybe there's one number, maybe the fine constant. He's talking about the atom with electron and nucleons, and it doesn't important. I don't know if you caught that part before, but he's like, oh, and the nucleus, which isn't really important. Of course, the nucleus is made up of protons, according to the standard model, protons and neutrons, and they're made up of quarks, which is kind of huge for the standard model, given that quarks make up half of the periodic table of subatomic particles, or whatever you want to call it. But what he's doing is he's saying, oh, well, we can calculate all this stuff. And then Alexander Unzicker says, well, wait a minute. Einstein came up and there was like a bunch of these variables. And he goes, oh, yeah, there's 19. Remember what I said? So he's contradicting himself. I'm going to back it up a little bit.
There's a lot of these arbitrary numbers that Einstein had.
19 in the standard model.
How does this?
In the standard model, there are, the order of a dozen or two parameters. But it's interesting. So my part of the standard model, my contribution was to the theory of the nuclear force.
Okay, so he pinned him against the wall and said, look, you're talking about everything's calculatable, but all of a sudden you have 19, and there's a dozen or two. You notice I said 23, a dozen or two. 2 dozen is 24. And then all of a sudden, he totally deflects the question. And he goes, there's something interesting. It's these guys, big science is just like big politics. The moment you say to them, well, trickle-down effect doesn't work. We know that. The best economists in the world can tell you why it doesn't work, and the average person can get it why it doesn't work. And then what happens to the politician? What's really interesting is we have a bill that's going to help veterans. So all of a sudden, there's two things that want to happen. He gets cornered, and he can't answer. He's not going to answer the question because it's simple, but now it's like 19. Oh, maybe there's a dozen or two, which now just past 19. But what's really interesting? My contribution, the second thing, me. I win the Nobel Prize. I'm a Nobel laureate. Where's my? Here we go. Here's my Nobel Prize. Part of my scheme in the future. Here's my Nobel Prize. Right here. See this? So he totally deflects it. Now he's, what are we, about 4 minutes in? This goes about 31 minutes. Well, he completely deflects the question. So for those of you who are like, I can't listen to these guys are super brains. They're not super brains. This idea that there are children that go to college at 10 years old, I've said this many times. What really happens is an acceleration. You don't hear the children at 10 years old becoming these super brains and there's a collection of no, they just get to adulthood 10 years before the average brain. That's all. So these people don't have supercomputing brains where they can do more than us. Even the people who have these special abilities to remember or multiply numbers or do something, it's not like they're super brains. Their brains are just differently wired. This guy is not a super brain. So when they're talking about all these things, we can understand it. We have to get over that. And so this guy gets cornered, says it's simple. Oh, not there's 19. Oh, there's 2 dozen. And oh, by the way, no, it's really interesting. Something else. And that something else is me.
Quantum chromodynamics. Quantum chromodynamics describes, ignores the weaker nuclear force than electromagnetism and describes the properties of the proton and the neutron and such particles. In that theory, one can, to a very good approximation, ignore the mass of the quarks, which we cannot calculate and must take from experiment.
Is that justified, ignoring
yeah,
gravity?
Gravity
matters?
Oh, sure. Gravity you can ignore. That's a mistake.
You can ignore gravity, and that's a mistake. I mean, I don't know if he said it about himself. This is like, it's incredible. I think how he got this interview, is my guess, is that he says, I want to interview you. So what's that mean? I'm a Nobel Prize laureate. See, there's my Nobel Prize. And you want to talk to me because I'm important. I'm an important person, and I'm going to talk. Look at the way the guy talks. Look at the way the guy holds himself. I don't think there's a humble bone in this guy's body. Although you can see, and you can watch as this video goes on, he's going to start getting madder and madder because he's going to find out that this guy, Dr. Alexander Unzicker, is trying to get questions and get into this guy to, and ask them real questions about the inconsistencies and the paradoxes and the double talk they do. These guys are no different than any of these politicians who really don't work for the people. They just work for the rich and the big corporations. They double talk, and they don't plan to do anything. They just want their paychecks, become lobbyists, make a lot of money. They don't care about us. Well, it's the same way with these guys. These guys just want to go around giving talks, talking about their stuff. Only, I think, and this is my own, but I don't think it's the only person that thinks this, these people, I think deep down inside, know this can be all wrong. That's why they start backing off, and that's why you sort of see them, they're never 100% convinced what they're saying. They're trying to convince themselves as well. But of course, we can ignore gravity, and we can ignore the calculations we have for quarks. We just get those experimentally. Of course, quarks don't exist, but that's another problem.
Calculating, say, the mass of the proton of 1 part in 10 to the 40. Ignoring electromagnetism is a mistake, 1 part in 10 to the minus 3. Ignoring the electroweak interactions, again, is 1 part in 10 to the minus 6. Ignoring the quark masses is 1 part in 100, at 1% level. But at that level, if you just consider a very good approximation to QCD, quantum chromodynamics, the theory, ignore the quark masses, then there are 0 free parameters. This actually is the
My goodness. I mean, can a look just tell? You know what's really amazing? I don't know. I'm going to have to ask Alexander Unzicker. Did you put in these things afterwards? Because I think if you would have done that during this interview, this guy would have just got up and left. But I think his ego's so big, he just doesn't want to see it. He didn't care. He's talking away. He's a Nobel laureate. He's important. So, but I mean, look at that. Look at the look on his face. Look at it. Look at Alexander's face.
But at that level, if you just consider a very good approximation to QCD, quantum chromodynamics, the theory, ignore the quark masses, then there are 0 free parameters. This actually is the first time we have a theory that's close to the real world in which even in the Einsteinian sense, all dimensionless constants are calculable. It is kind of surprising because there's a force. It's very similar to electricity and magnetism, and there's a force, and clearly there's a number that you would have thought was like the electric charge. It tells you how strong the nuclear force is. It's quite strong, has some value. But there are no masses. And what happens is something that is related
to ignore the masses.
Of the masses of what?
The masses of elementary particles.
No, of the quarks. So the mass of the quark is 1/10 of 1% of the mass of the proton. So let me just.
Accepted model. This is
No. Except that measured. We can measure indirectly. The quarks can't be extracted because of asymptotic freedom from the proton. But you can infer by observing at short times how they move and measure their masses. They are of the order of electron volts, a few electron volts. The proton weighs 1,800 electron volts, almost 2,000 electron volts. Sorry, I'm getting away.
I even see something here, and that's quarks make up protons, and he's saying that it's like, what? If a proton is a 1,800 and some electron volts, and a quark is just a couple electron volts, how can 3 quarks make up a proton? That would be 3 electron volts, 4, 5, 6, for 180, 1,870 or whatever the number is. And you notice when he starts talking and he says these things, he catches himself when he says these things, how these things don't make sense. It doesn't make any sense. So you have this entire conversation going along. He's pontificating. In fact, you notice he's looking into the camera. He's not looking at Alexander Unzicker. There's 2 reasons for that. One, he's used to just lecturing. And Alexander Unzicker is asking questions. Number 2, he doesn't want to look at Alexander Unzicker because he's asking him tough questions and showing the paradox. It's only just going to get worse.
Million electron volts compared to billion electron volts. But let me finish. So if I calculate, so what happened in QCD, the only free parameter in a sense is not the strength of the coupling, but the size of the proton. That's a dimensionful parameter. And Einstein talked about numbers, dimensionless parameters. The ratio of all the masses of the hadronic particles, the proton, the neutron, the rho meson, the sigma, dozens and dozens that we've so far calculated, all of those ratios of masses, which are pure numbers, can be calculated and have been calculated. And the quark masses give 1/10 of a percent correction. All of them. I showed you. There was a slide which had the mass spectrum. The lattice QCD has been... Now, so that's a theory, the first theory we've had, in which there are essentially no uncalculable parameters at its heart. Then there are the quark masses, which come from the Higgs sector, and small corrections. Now, if you're really a stickler, however, as Einstein was, he would have said, okay, you have a theory where you've explained the charge of the strength of the force. You've explained the ratio of masses. You can't adjust them. However, you could adjust.
Where precisely is it calculated? I mean, something like 1836 or...
Well, you need to... only...
Precisely, where
you
does
want
this
a source?
come out precisely?
Well, what do you mean, where do they come out? You put you solve the theory by formulated on a lattice.
You mean
space time.
lattice QCD?
Lattice QCD is a precise numerical, controlled numerical solution of the theory.
Yet the result is about to a 4% accuracy.
No. Better than a percent now.
And but even if it's better than a percent, the difference between neutron and proton mass is like.
That's
0.2%.
electromagnetism. In the
0.2%.
yes, of course, because that depends on those quark masses, very sensitive. The difference in the mass of the proton and the neutron, which is a fraction of a percent, is.
Okay, I don't want to lose you guys on this, but basically what's happening here is no different from you trying to ask any type of politician very specific questions. You find that this person is answering it or not answering it. They divert to something else. They realize that they're in a corner, so they just say, well, oh, yes, we've calculated, you saw the slide. It just gets worse and worse and worse here. So I'm going to go ahead and watch. Now, I wanted to show you just near the end here, where now he's getting to the point where he's not liking any of this. He's getting the idea that, oh, I'm being interviewed by somebody who's a critical thinker, and they are literally, they know what they're talking about. They know where the inconsistencies are, and it's making me upset. Now, you're going to see he's going to start to get on the edge of his chair, and that's where, things get a little bit, well, he ends up getting up and leaving, so.
Tend to have discussions with are skeptical for the wrong reasons. But physicists in general are skeptical. We all know the history of science. I know the history of my own career in science. A lot of our ideas are wrong. That's why we do experiments. It's elementary. But with the LHC, to conclude that one hasn't discovered something very difficult to see immediately, and therefore boom, 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 where you've just begun to carry. So these skeptics are usually outside of physics. They have no influence over the decision to close down the LHC in the end of 2015, because in the first 5% of their program they haven't made it. Haven't discovered.
Last question. So you're a famous theoretical physicist and got the Nobel Prize for theoretical work. Have you ever had the chance, to how much detail have you had the chance to enter in these experimental issues?
How do you think I began? What do you think I was doing? How do you think I made my discoveries?
Have you ever heard about the book Constructing Quarks by Andrew Pickering? Is that
stupid book?
You think it's a stupid book?
Yes, absolutely.
Yeah.
Okay, what he's doing is he's bringing up one of the books very similar to his book, which is, again, this is recommended. Everybody must read this, The Higgs Fake. Basically, he's bringing up this other book about quarks, which, of course, he's saying, well, the quark book, and I will definitely, I don't know, let's just show more here. I don't know if he talks about it. Oh, here it is. The book, controversial book, Constructing Quarks, by Andrew Pickerington. Okay, so that's a very good book to take a look at. I haven't looked at it myself, but I am pretty if I understand it right, what it's basically is when he's saying constructing quarks, it's not the case that they found them, in fact. So what he's saying is this is totally stupid. Now, instead of bringing up what the guy said and making the argument, this is one of the things I have pointed out in many of my other videos, and that is people will go immediately to this idea that that's stupid, that they won't make any comment as to, well, I did read that book and there's some valid claims, but I think some of this claim and that claim, no, it's just stupid. So one of the problems is that mainstream physics will not look at the criticisms. The good thing is there's very few of them, and there's many more of us. And now with the internet and these things like this channel and Dr. Alexander Unzicker's channel, other people's channel like mine, our organization, naturalphilosophy.org, you can go there. Our new website that we're working on called sciencewoke.org, which is going to let every average person basically who loves science understand where these problems are and explain them in an interesting and fun way. But you know, he again, he's getting to the point where you can see he's frustrated. And we're just going to play it. Let's see how many more minutes we have. 28. We're going to do the 3 minutes. I'm going to go a little, okay, right here where he's up close, and then we'll just go to the end so you can see him at least walk out.
Serious doubts on the entire concept
Of what?
of post-war particle physics, of the description. I mean, certainly we have descriptions, these descriptions, but
You mean
the question
at
is
this
if,
point?
if this is
He's
unique.
making is this unique?
Yeah.
That's the criteria? What do you mean unique?
I mean, well, unique is geocentric
Could there
astronomy
be
is
some
a
other-
description of planetary motion, but it's not unique.
Yeah, that's right. There's good old Aristotle and Ptolemy. My God, and they're equally valid because, as Pickering says, there is no real truth. It's just an agreement between political
I don't
actors.
agree on that.
Anyway,
I don't agree on that. Okay,
you know,
so
this
one
is
thing
not
one thing we agree.
not worth discussing.
Okay.
So my criteria of what is in physics, a very joking remark, is if once it enters the history book, the high school textbooks, it's there to stay. You know, Newton's theory is there to stay. By the way, Mr. Pickering, Newton's theory, we know is kind of wrong, but it's not going to go away. The Standard Model has passed such an incredible number of experimental tests. And I would suggest, Mr. Pickering, or you, go look at the data. You know, immerse yourself in the phenomena that you asked me about. Look at what's coming out of the trillion events per second at the LHC, all of which, unfortunately for them and for me, are with incredible precision, over 20 orders of magnitude, described by the Standard Model. So Pickering might have had a point, he and Derrida and that crowd 20 years ago. But luckily, anyway, he doesn't today.
Okay. Anyway, I seriously appreciate the conversation.
Okay, folks, you can see the guy gets up at the end. He's very frustrated. What if he's frustrated there for, if you didn't catch it? You can go back and watch it if you are so inclined. But basically, he was super frustrated for the fact that the idea that there could be uniqueness. Because when uniqueness, once it's in the history books, it's a fact. That's basically what he's saying. Unzicker was saying, well, what about uniqueness? Meaning, you can describe planetary motion in various ways. It's the same thing that we have today outside of the mainstream, and that is we have numerous models that are competing right now because we're still in a model revolution. We don't know which model is the best model. We have at least 3 or 4, and that's where we're at until we get more and more, keep working on those models and maybe testing those models, I don't know, experimentally, if we can find anything that would differentiate between them, then we're not necessarily, no. Can we actually have more than one model describing the universe? Yes. Do we have more than one computer language that does the same things? Absolutely. You have different computer languages that make browsers on your different on your phone, on your tablet, on different operating systems. None of them are the same. They're using different languages. Some of them are using similar things, but they're all different code. But they do this, hopefully do the same thing. So the whole question of this idea of uniqueness is a bigger question. And you can tell in the end, he was, he just got up. He was just saying, okay. And also he made this other statement. All these statements, if you go to some of my previous videos. Some of my more recent ones, well, I can't remember which one, but I did talk about this whole idea of, I think, well, this is Alexander Unzicker. So just go back to, I think I have 2 videos, recent videos. If you're watching this, look around the time, a few videos before this, the Higgs Fake 1, Higgs Fake 2. And he talks about exactly these problems where people say it's been tested 1,000 million times. Well, you can never prove anything. And you can never, that's one of the problems. That's what Neil deGrasse Tyson, that's one of my, I think my 3rd most popular video. Neil deGrasse Tyson says relativity has been proven, millions of times, hundreds, it's proven every time you use GPS. There's nothing that can be proved. You have a model, all you can do is have your model try to fit the way the universe works and describe it. If it is useful, then we will use it. Let's take Newton, for example. We use his equations constantly to build buildings and to actually fly into space, all the spaceships. We're not using quantum mechanics to do that. We're not using anything that has to do with relativity. We're not using that. When we say we're using relativity to find planets, we're not. What we're using gravity wobbles, and we're also using light that goes in front of the stars, and we also use the bending of light in the coronas of stars, not because of space-time. So this whole idea that these things, that in particle physics, this guy was talking about his quantum colorful theory, chromatic, whatever he calls it, and you question him on his own doublespeak and his triplespeak and his paradoxes, and then what he goes into the mode, they're just absolutely wrong. That's the same thing. I know the most recent one I've done of my videos. I talked about the 2 Danish physicists who were showing and trying to show very technically why the blips that they found for supposedly gravity waves were not correct. And the guy says they're categorically, absolutely, positively wrong. These are not scientific arguments. Scientific arguments, that's just nonsense. Those aren't arguments. So they're not going to look at them. You can see he's uncomfortable. And these particle physicists, the good thing is they are very few and far between. How do I know that? Well, I had my mom call up, just take a person who's an expert in relativity. Turns out there's only one person in the United States who I would say could be literally, their career would be built on relativity, and that's, now I'm drawing a blank, Kip Thorne. Kip Thorne of Caltech. He won the Nobel Prize, of course, in 2017 for the blips that they pretended to find or not in the LIGO detector, which was to detect gravity waves. So they sort of threw three people together. One's a general relativity guy, and so sort of. His fame got him via relativity, but when my mom called up universities, there was nobody who if relativity rules the universe, as the physicists say, why does nobody major in it? In fact, the only thing we got was, so-and-so, yeah, they teach it, they know a little bit more, yeah, that's sort of, he knows more about it in our area than anybody, talk to that person. So watch my film, EinsteinWrong.com. You'll see a conversation with a real physicist from a university who agreed to be on in the movie, and it's very interesting to listen to their arguments when they're put against the wall for relativity. But again, I find this really fascinating to go and take a look at these guys who we say are building unicorn worlds, and listen to their speak. Again, if you, one of the things I'm going to be doing in the future, once we get our sciencewoke.org out, I'm going to be going on the progressive side of things, and I think a lot of progressives politically are going to be very interested in the progressive ideas of the critical thinkers in the Science Woke and our organization and what we do. I have some very interesting thoughts about that. I'm saving that for that website. Okay, let me see if there's any questions or any comments here. Dave, as my father used to say, he was on the muscle. Ooh, that's interesting. Explain that to me, Lisa. Let's see. Let's go back here. Dave Capitals won't look at the criticisms of systems. I'm going back here. Alrighty. Whoa, lots of talking with you guys there. Supposed to subscribe guys for your information. Thank you, goodness. My phone knows what we can put. All right, I'm going to keep moving here. I'm looking at the comments. Over Unity. Over Unity, I guess, is the idea that you can get sort of more energy than you can, that is supposedly there. Of course, that can't happen anywhere in the universe, but you can. The idea that gravity is a particle and it's coming down light, we get the energy from, or get the movement and can store it and use it for other useful things. Gravity is there. Can it be perpetual? That's a good question. That's something we can, I think, you got to know what model you're using. So it depends on your model. So that's the answer to that. Thank you. I'll be hanging around for a little bit longer. I thought it was also good to handle. Thumbs up. Outline of the broadcasting. Dave, that's a good comparison in terms of the politicians. Absolutely, yeah, absolutely. And that's why I have this new website and hopefully to get out to even more people this whole thing. The Dissident Science are for people who are really into the science, but there's a whole side of science in general. Progressives don't know that big science is pulling the wool over our eyes. They read this stuff and excuse me, a lot of the intellectuals will say, oh yeah, it must be true, and I would just need to learn about it. Dave, capitalists won't look at the criticisms of the system either. Yep. Look like they're comparing things. Absolutely. This is great. Thankful. This is great. Thankful. Okay. Bell clicked. I've been missing out here. Okay. Oh, great. Thank you very much. I appreciate it. That's F417H. That's good that people are coming on. Also, I see I'm losing some people here. Channel sharing, good. Dave, as my father said, okay, I didn't know what that is for. About Dave, is he's okay with people having other models? Absolutely. Yeah, absolutely. In fact, I applaud anybody who does that. To me, you have to remember, one of the things is I've been involved since 1992 with dissident scientists who's actually come toward me because I'm an artist and a scientist. So they think, hey, bigger thinker, maybe he can help me get the word out. It's really funny now that it just hit me right now that my mentor came to me with those kinds of words. And here I am. I'm a super proponent of his work, student of his work, and Dr. Karazani, autodynamics.org, take a look at it. One of the great science minds of our time, of our generation. There are many, but none of them you've heard of. Have you heard of Glenn Borkert? You should. Have you heard of Bill Lucas? You should. Have you heard of Ionel Danu, Dr. Danu from Romania, and his experiments? Do you know about that? That somebody should know. Do you know Stephen Hurl, the mechanical engineer from England, that has the book, another book that you must read, Dinosaurs and Expanding Earth? All these people. So, I've hung out with them. So I have a really soft spot in my heart, I guess, for these people because they've been fighting many times alone for decades. Dr. Karazani fought for 5 decades before he met me, and now his work is just getting out, and more people do read it and understand it and do think that perhaps his is the best takedown of special relativity, of why it's wrong, and that the equations that come out of it can be used to do much more simpler calculations for like the Bohr's atom and nucleus-nucleus collision. Again, autodynamics.org. So yeah. Losing people. Kip Thorne noted. Yeah, all right. Easy cheesy. Good film recommended for beginners. Yeah, hopefully that's my film. EinsteinWrong.com. Go there for $3. You can see it. The $3, what does it do? Well, it helps pay for the site to keep it up there so people can watch it in a nice manner. I don't make very much money, a couple $100 a year maybe. Great movie though. If I could ever get a distributor, or get it onto a channel, I think it will happen someday. Dave, my father's on muscle just means ready to leap up or uptight, basically on the edge. Okay, gotcha. I overflowed to your forum, Ingram Draft Science. I overflowed to you from Ingram Draft. I will look up all these names. I grew up on dinosaur provincial parks. are very interested in this topic. Well, thank you very much. I know Draft Science does send people my way, even though he had a video that really lambasted me, but I don't really care. Again, I'll look at it as, it's his personality. I don't care. I'm not sort of that shock person. He's more of a shock person. I swear, yeah, I do, but I don't need it too much. I think we can say shocking things without needing to swear up a storm. Although, believe me, when you drop a bowling ball on your foot, yeah, I swear at those kinds of times. Yeah, I'm not a very religious person. I'm not a person that has super high worries about those kinds of things. But at least here, I'm not into that. So he does that more. He has his own theory, which I think is great. He's trying to get that out. So again, I applaud him, even though he probably hates my guts. He calls me names. Well, he called me some real bad names in the title of his videos. But, he's trying to create critical thinkers, and they come my way. Believe me, every time they talk about him, I do get people in my direction. That's great, because I think the CMPS is the best organization on the planet for scientists. Because why? You can get up in front of us and challenge anything as long as it's scientific and done in a scientific way. We don't take we only take things with really related to physics, cosmology, mathematics as it relates to physics, or sometimes pure math, which we have Peter Erickson, one of the great heroes of math. I think he's one of the best mathematicians alive. But and also philosophy, we do talk about that. Structures is another whole area we haven't talked about. I'm going to try to get some of the structures people on. So, all right, but no problem. And I'm going to take a look at, let's see, I've got a few more minutes here, and I'm going to take a look at science. I want you to see how myself as a critical thinker who have been around these great minds, who, in my opinion, science, the people I know and hang out with are the ones that are going to be the people that have made science go forward. That'll be household names in the future, and then other people come up with even better stuff. So, that's, I wanted to show you how I take a look at these with that perspective. And a lot of times you get things you don't know, and that's why you want to click on the subscribe button right down there below and that little bell next to it, like that one guy, and thank you so much. And here, let's go forward with the news, and I'm going to go through this. If there's something that's not interesting, I'm just going to pass by it. Scientists capture the sunrise. I like those things. I love space. Grew up in the Apollo area. Graphene on the way to superconductivity. I'm not going to really look at that. Quantum compass, allow navigation without really relying on satellites. These are more technical stuff. I can talk about these sometime. This one you got to click on. Come on. Hawking's final book suggests that time travel may one day be possible. Now, I will be honest with you. The reason Stephen Hawking was very, became famous wasn't because of his physics. It was because of his physical problem that he had. And yes, it's a great human story which merited a film and all that. That's great. It's a human struggle. It's the human side. The same way with Einstein. He's got the big hair, and he was a patent clerk that just came out of nowhere and showed the world about new and amazing things, which of course he's wrong on all of it, but the people love the stories. So let's click on this, because it's not because of Stephen Hawking. Well, it is because of that, because we need to, I don't care who it is. When you talk about suggest time travel, folks, time is movement. Movement you can't undo. You can't take the universe and have all the particles all of a sudden go backwards or something. And even if you could, how could you you'd have to have everything do it. You wouldn't know it's happening. It's crazy. It's just crazy. And of course, this is one of the problems. Of course, I need to show you the browser, don't I? Here we go. And I'm showing you, okay, let's go back. I'm showing you a page which I wasn't showing you. Let's go back to it. This is science. This is physics under Google, which I like to go to. And I'm going through here talking about things and wasn't showing them. And I apologize. Those who are just listening, laying back. So I went to this one, Stephen Hawking. And of course, I'm going to get rid of this one here. And we have, of course, one of the problems that we have in physics is great graphics, great programs, great three-dimensional graphics. So, Stephen Hawking's time travel. Oh, it must be, look at that picture of time travel. And, in movies, you literally go through these tubes. It's really, really amazing because, they just want fantasy. So they want to have fantasy here. I made a research giant application, blah, 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 blah. Let's see. Light speed. Let's start with everyday experience. We take for granted the ability to call our friends and family. What is this? This is probably... I'm not reading this. I'm not prepared. Einstein told us that space and times are parts of one thing, space-time. Listen to the logic here, folks. Listen, you got to just be... Look, I'm your science therapist. I'm going to break this down for you, why this right passed right over you. Space and times are parts. Okay, I'm just going to do math. 1 plus, let's just call it S for space, and T. Now, those are two different things, right? They're parts of one thing. No. This one thing is made up of two things. You can see that. And that we should be willing to think about distances in time as distances in space. Here's the main phrase there. You can't see, it's pretty small. We should be willing to think. Look, it's not willing or not. What you need to do is be like, I don't know, Aristotle says a brilliant mind is one that can come to anything with skepticism and not accepting it. So that is, talk about it. I'm listening to it. I'm constructing whatever you're saying. I'm not accepting. You should be willing to think about it. Yeah, we should be willing to think about it. But this is the problem. We should say what they're really doing is they're browbeating you and to say, well, look, you've got to think about this, because if you don't, then you're just not a critical thinker, even though this makes no sense from the beginning, because I don't even believe in space. And space is nothing, time is movement, and space, putting those together and making a thing out of it, read Glenn Borkert et al. As odd as this may sound, we happily answer about 2.5 hours when someone asks about how far Birmingham is from London. When we ask, that's how we ask. So he's saying, of course, we should just think of time. It's just like travel. I can go to Birmingham, going from Birmingham to London, so I should be able to go back. Mathematically, our statement is equivalent to saying that Birmingham is about 125 miles from London. As physicist Bob Cox write in their books, Y does equals MC squared, time and distance can be interchanged using something that has the currency of speed. Look, mathematics does not equal the physical world. In fact, it doesn't ever equal the physical world. What we do in physics, for those who want to know the big picture of what's going on, is that our job is to try to come up with models. We're curious, how does it work? Because guess what? What happens when you can figure out how it works? You can then take it and manipulate the world. Newton is so good, he lets us make gigantic skyscrapers. He allows us to build machines that go into space, that can take us, human beings that shouldn't be there. All those calculations are forces using his equations. Does a spaceship have force equations in it? No. It's a bunch of atoms and we put them together. So what we try to do in physics is to try to come up with models that will actually model the world, and then maybe even manipulate it to make it a better world. But no, we're talking about, we can interchange distance and time as a currency of space. It's math. It means nothing to the real world. Einstein's intellectual leap was to suppose that the exchange rate from time to a distance in space-time is universal at the speed of light, which is false. For those of you who do not believe that the speed of light is a constant, then you need to learn. What I would suggest to you is to read up on our website and to also realize that constants in the universe are things that we come up with. The idea that something would be perfectly the same speed is ridiculous. And the answer we have, what do I give as an answer? If I tell you, infinity. That's what's infinity? Well, infinity means that there are no you can't find the ultimate particle. You keep going up. There's bigger and bigger and bigger structures. For infinite, we're part of a chair or something. We could be an atom. Some people have proposed that our solar system is a barium atom. And then you keep going down, going down, going down. Well, what does that have to do with the idea that, oh boy, I lost my train of thought. Somebody help me. Sorry, folks. I'd have to go back and listen to what I was saying. I was talking about equals mc squared, time and distance. You can use currency speeds, intellectual leaps, suppose exchange time and distance universally. Oh, this constancy of the speed of light. Okay, constancy of the speed of light. If you go with infinity and you understand it, read Glenn Borkert. Infinity has some implications. One, no two particles are the same. Are any two suns the same? They're not. Why do we think that? How could you perfectly, if electrons are made of something smaller, which you believe in infinity, it's always made of something smaller, then it's gonna be perfectly the same? No, it'd be an infinite amount of ways down that everything would have to be the same. No. So infinity has its implications. Don't take my word for it, read it, but this is what you learn, and that is so no particles are the same. So the constant value of speed is really more the average speed of what we see where we are. The speed of light is not always c, because the speed of light in water is slower. But we have models that explain why. Anyways, all those kinds of things. The speed of light is the fastest any signal can travel. Depends on the model you're using. In infinity, that's not true. Putting a fundamental limit on that is somewhere in the universe called causality. Now the speed of light must be a measure of the same. However, fast we ourselves are moving. It doesn't matter. Exactly. He's talking about Einstein. The solar clock ticks, so they're talking about relativity. Unfortunately, it's not wormholes. Einstein also told us that the force of gravity is consequence of, talking about wormholes and warps and quantum mechanics, saving history. So this time travel really possible, or currently understanding can't rule it out, but the answer is probably no. Anyways, M theory requires space-time to have 11 dimensions. There's only 3 dimensions in the world. Other dimensions is because they're taking length, width, and height, x, y, and z, and saying, well, I can draw, I can imagine another one, even though you can't draw it. Anyways, whether or not the future has machines in store, we can comfort ourselves with the knowledge that we climb a mountain or speed along in our cars, we change how time ticks. For those of you who don't know, clocks can slow down, and they do slow down. No matter what clock you make, even if it's an atomic clock, it is a physical clock. It's not a virtual clock. It's made out of real physical things. And when you have real physical things, this is called clock retardation. This is why I'm here. I have this channel for you. That is, when you take a clock on a satellite and you shoot it up into space, it runs at a different speed. Why? Because there's less gravity, there's microgravity, and microgravity affects atomic structure. It does. It affects us. We're made of atoms. So they say, oh, look, the time slows down. No, the clock slows down. Time doesn't slow down. Movement still is movement. Doesn't change. Doesn't move different. Anyways, interesting. Let's go back to here, two-atom quantum duet. This probably has to do with the spooky action of the distance. That comes from quantum mechanics. Oh, Dave, what do they say about it in the outside the mainstream where maybe they're ahead of everybody else? Well, it turns out that quantum mechanics and all the experiments and all the assumptions of particles knowing what about other particles is because they're models for what's going on during the double slit experiments are flawed. They don't know what's going on. They don't know what light is. They don't know how it works. They don't know how. They call it a particle. They call it a wave. They don't know what it is. They don't know how electromagnetics works. They don't have how magnetic fields work. They don't know how that interferes. They none of that. And that's where all this confusion comes from. Once we have a model, all that goes away. Black hole 10 times heavier than the sun is spinning at almost light speed. Okay. What's a black hole? For those of us who don't believe in infinite points with infinite mass, which we don't believe in, black holes are simply very, very dense objects, most likely nucleons all smashed together, because that's most of the, and if you have nucleons, depends on your model. Okay, let's take my particle model with my father and I's particle model. What does it say? If you have nucleons there, you don't have electrons going around it, or what we call G1 particles, and any radiation that would come from it means that there are electrons there. So if you take all the protons and you put them all together, well, what you don't have anymore are things orbiting it. If you don't have anything that's orbiting it, then you're not going to have any gravity coming out, and you're also not going to have any light coming out, because light are the electrons, or G1 particles we call them, coming out in waves of particles. You don't have them, so you don't see anything, but they're all nucleons. That's our explanation for our model. But you have to have a model to be able to say that, folks. Pick your model, pick your poison, whatever. Electric universe people, they have their model. Cool. Quantum systems, same but different. Yeah, there you go, same kind of thing. Okay, that would probably be interesting. A brief history of timekeeping. I'm going to be going soon, so let me see if there's any questions here. I think you will really like this alternative research. It's not mainstream, very thorough though. Let's see. Just YouTube search for Richard D. Hall. Really interesting stuff. Richard D. Hall. Wonder if I should search on that. Let me go offline before I search on it and then find out that that's something the wrong Richard D. Hall. This is Lisa saying go to Richard D. Hall. So okay, I will try that out. Let's see, Richard. Maybe it's like it's not even science. Maybe she's into other things as well. Let's see, Rich Planet TV. Space program, finding secret space program. Don't know. I'd have to look at that more. I'm not seeing it right away, seeing what that is. Let's see what else we have here. Quantifiable Earth, barium. Yep, barium. It could be. Glenn Borkert. Let me go look him up and show you that. Just go to Amazon, and that's B-O-R-C-H-D, no, B-O-R-A-C-D-H-T. It's a weird name, believe me. Infinity. I wonder if I can just type in infinity, see what it says. I'm not showing you this until I get, there we go. It's because my computer's overloaded. Infinity. Glenn. Come on, Glenn Borkert. There we go. I'll show that to you. All right, this is the. Let me show Glenn for you. That's Glenn right there. Must read. Infinite Universe Theory, must read. Universal Cycle Theory, I recommend it because it has a little bit different perspective on it. The Scientific Worldview, must read. Then they have the 10 Assumptions of Science, but that's part of the Scientific Worldview. So I would read either the Scientific Worldview or any of these books. They're really great books. For you, and there's his spelling. Somebody says draft science has similar ideas. There are some, yeah, I would say. There's a claim that I'm not sure. There's things about his model that I don't understand. He has a lot of things in the model I don't agree with. Again, I think it's great that he has it. You can look at it, you can agree with it. I think it misses infinity, which is huge. Any model that just doesn't deal with that has to have special model. The idea, why do I say that? If you don't have infinity in any model that you have in the future, well, then you have to explain how the ultimate particle, which makes up everything, organizes itself by itself. So you have to imbue it with magical powers. What's a magical power? Charge is a magical power. You put a plus sign on an electron and put a minus sign on a minus sign on an electron and a plus sign on a proton, and they attract. When I know that I had an interview or two with Draft Science, and he was just livid. He was so mad at me for saying that there wasn't charge. He says it's a fundamental thing in the universe. It is not. But so there are some things that definitely I'm not agreeing with. Can mass accelerate past the speed of light? I do have go look up that. The speed of light, speed of light in dissident science. The answer to that question is depends on what you're using and what model you're using. Right now, with the techniques in the model, in the technical know-how we have, you can't go faster than the speed of light. The reason is everything we are using to try to go faster is not going faster than the speed of light. Are there things in our model that go faster than the speed of light? Absolutely, and a level down from what makes light, what makes electrons go around a nucleus. Another level down is a gravity particle, but it's going at c squared. So if we were to do G1 particles then could communicate to Mars in a fourth of a second. They're going very fast, but can we get G1 particles to accelerate atomic structure? It's tough because it is itself keeping atomic structure together. So that, again, if you have a model and you give it to somebody, they're going to be able to figure it out. If our model turns out to be a good model of the universe, somebody can then go and use that. So that's the answer. So using today's technologies that we are trying to use, we don't see it. We have to have a brand new model, like our particle model or some other model. Rich Planet TV, yeah, I see. Science, see Borchfik comment above the link. Okay, folks, I am going to take off, I think, here. I've got 11 or 10 people watching. Do you have any questions? If you do have questions, I'll give you a second here to take a look if you want and ask me. Merci. My French is bad, although I want to go to France, but of course he can be from anywhere. There's many countries that speak French, so you're welcome. Could be Quebec. But thank you, and hope you all have a good night. And remember what I always say, stay critical and stay thinking. Don't take my word for it. Read it for yourself. I'm Dave D. Hilster. I'm your science therapist. Ciao for now.